There's a really interesting thing about these neutron star collisions. So the material that neutron stars are made out of, it's mostly neutrons, as it makes sense from their name, with some amounts of other things. And when you have a neutron star collision, you have two neutron stars approaching towards each other, and if one of them is more massive than the other, the less massive one will kind of get slightly ripped apart. In any case, when they start colliding, they'll start of smear some mass off of each other, and this mass kind of gets thrown out into space. So this mass has lots and lots of neutrons, and so it kind of breaks apart into little bits, little nuclei that are really neutron rich. And these things decay a few times, and eventually you're left with this kind of mush of very heavy elements, things like gold and platinum and such. Now, it's been a question that astronomers have struggled with for quite a long time to explain exactly how we get, say, the gold in wedding rings and such. Where does that actually come from? It's been suggested that the process that makes this might happen in supernova explosions, at the deaths of massive stars, but the conditions there don't seem to be quite right. The calculations people have done suggest that it doesn't quite produce them in the right numbers. Whereas the smashing together of neutron stars has seemed like a plausible scenario for how you might get that, because of it being so neutron rich. So the recent discovery of a gravitational wave observation of two merging neutron stars was really interesting, because we were able to catch the actual optical, infrared, X-ray, radio observations of this right afterwards, and especially the optical and infrared data strongly indicated that we actually were seeing the production of these heavy elements, such as gold and platinum and such, that are needed, and that we weren't able to identify exactly how these were made.